Hi everyone, welcome back to Algorithm with Chelsea. Today we're going to do some fun number magic in Python. We'll learn how to look at a number's last digit and how to remove that last digit. Once we can do that, we can solve cool problems like counting digits and adding digits. Let's review modulo and integer division. We can use the two operations to peel digits like peeling an orange. Let's use the example. N equals 2026. First tool, modulo 10. When we do n modulo 10, we get the last digit. 2026 modulo 10 is 6. Second tool, integer division by 10. When we do n integer divided by 10, we remove the last digit. 2026 integer divided by 10 becomes 202. Now let's see it in code. We set n to 2026. Then we print n modulo 10, which should be the last digit. Then we print n integer divided by 10, which should drop the last digit. Pause and guess the output. Here's what prints. First, 6. That's the last digit. Then, 202. That's the number after removing the last digit. Now another example. Try n equals 5. We still do modulo 10 and integer division by 10. Pause and predict what prints. The last digit of 5 is 5, so modulo 10 prints 5. And 5 integer divided by 10 is 0, so integer division prints 0. That 0 is important because later it helps us know when to stop. Here is a useful loop trick. For underscore in range of n. In Python, many people use an underscore instead of a specific variable name. It means, I'm not going to use this variable. Look at the code. This loop runs 3 times, and each time it prints the word hello. Here is the output. We get hello 3 times. 1 print per loop. You have learned all the prerequisites. Now let's solve the problem of counting digits. Goal. Given a positive integer such as n equals 2026, how many digits does it have? For example, 2026 has 4 digits. Here is the idea. Keep removing the last digit using integer division by 10. Meanwhile, count how many times we can do that. When n becomes 0, break the loop. For example, n is 2026. After repeating integer division 4 times, n becomes 0. So we know n has 4 digits. Here is the Python code for counting digits. In this example, the input is n equals 2. In the beginning, set count to 0. We run a loop up to 100 times. That's just a safe big number, because we haven't learned while loops yet. Inside the loop, we first check if n is 0. If n equals 0, break. That means, if there is no digit left, stop looping. If n is not 0, we do 2 things. First, add 1 to count. Second, set n to n integer divided by 10, which removes the last digit. In this example, the input n equals 2. After only 1 removal, n becomes 0, so the next check breaks the loop. In the end of the program, we print count. The output is 1. It means the input number has 1 digit. In the second example, we use a bigger number, 2026. Same code, same idea. Count how many times we can peel off 1 digit. Let's trace the variables. At the start, n is 2026 and count is 0. After 1 loop, count becomes 1, and n becomes 202. After 2 loops, 2 digits of n are removed. Now, count is 2, and n is 20. After 3 loops, count is 3, and n becomes 2. After the 4th loop, count is 4, and n becomes 0. Now n is 0, so the code breaks out of the loop. That's how we stop early. Here is the output. Count is 4. 2026 has 4 digits. Now let's do another classic digit problem. Sum of digits. Goal. Given a positive integer such as n equals 678, compute 6 plus 7 plus 8 as the sum of digits. The algorithm is similar to the previous. We will still peel digits, but this time we will accumulate the digits into a total. Here is the basic idea. We'll peel digits again, but this time we keep a running total. So we use an accumulator, total, that starts with 0. In each loop, get the last digit with n modulo 10. Denote the last digit by x. Then add x to total. Total accumulates the digits one by one. Remove the last digit from n by n modulo 10. Break when n becomes 0. It is because no more digits can be added to the accumulator. We turn the idea into Python code. In this example, the input n equals 678. Total is the accumulator starting with 0. Now the loop, 4 underscore in range 100. Again, 100 is just a safe big number. We do not actually want 100 loops. We want to stop when n becomes 0. Inside the loop, if n equals 0, then break. Otherwise, we do 3 steps. Step 1. X equals n modulo 10, so x is the last digit. Step 2. Total equals total plus x. It means we add x into the accumulator. Step 3. N equals n integer divided by 10. It means we remove the last digit of n. After the loop ends, we print total. It is the sum of all digits we peeled off. Let's trace the variables. N changes from 678 to 67, then 6, and finally 0. Each time, the last digit is removed. The digits we peel off are denoted by x. They are 8, then 7, then 6. Total starts at 0. Each time, we add x to total. Add 8 to get 8. Add 7 to get 15. Add 6 to get 21. The output is 21. It means all the digits of n add up to 21. Now it's your turn. We want the sum of digits of 2026. There are 2 blanks. One blank is for getting the last digit. The other blank is for removing the last digit. Pause the video, fill in the code, and try to predict the final printed answer. Let's check the answers. To get the last digit, we use modulo 10. To remove the last digit, we use integer division by 10. Now let's quickly sum the digits. 2 plus 0 plus 2 plus 6 equals 10. So the output is 10. Let's wrap up. Modulo 10 gets the last digit. Integer division by 10 removes the last digit. We learned counting digits by removing the last digit until n becomes 0. We also learned summing digits by removing and accumulating the last digit. This concludes our lecture. Thank you for watching. Please subscribe to Algorithm with Chelsea so you won't miss future updates.